Isomerism. Isomerism. In the previous class, I have explained how we can draw the structure of the family of alkane, alkene, and alkyne. In today's class, we are going to learn isomerism. Oloruntoba Kayode Segun is my name. What is isomerism? As you can see on your screen, isomerism is the existence of organic compounds. It is organic compounds that exhibit this kind of property. Isomerism is the existence of organic compounds with the same molecular formula. Note this one, molecular formula, but different in molecular structure. We can even say structural formula. So when we are defining isomerism, these words are very important. They are very important. Isomerism is the existence of organic compounds with the same molecular formula but different in molecular structure. So when we say molecular formula, we mean CnH2n plus 2 for alkane. Every alkane will obey that formula, but you can draw their structure in different way. Now let me show you some basic rules in isomerism. Look at this. Isomerism starts from butane, which is carbon number 4. A carbon number 4 is where the isomerism starts, which means that that carbon number 4, you can draw it in different ways, and that is why we call it isomerism. You cannot have isomerism in carbon 1, you can have isomerism in carbon 2, even carbon 3 can't give you isomerism. But starting from carbon number 4, we have what we call isomerism. Another thing is that when you are talking about isomerism, we consider what we call carbon with the longest chain. Carbon with the longest chain. So carbon with the longest chain is regarded as parent carbon, and we are going to name that parent carbon first before we even consider branches. So in isomerism, we have what we call isomers. So isomers are the product formed, are the compound formed after isomerism. So isomerism is just a phenomenon. Isomerism is a process. The branch that are formed are regarded as alkyl. They are also homologous series themselves. We call them alkyl group. So alkyl group are regarded as branches. They are regarded as branches, and number is being ascribed to these branches. So if an alkyl falls on carbon number 1, you must ascribe 1 to that alkyl group. If an alkyl group falls on carbon number 2, you must ascribe number to that alkyl group. And that is why I said numbers are ascribed to position of the alkyl group. And lastly, the position of the alkyl group must have the lowest number. I explained this in the previous class as well, that when you are naming organic compound and then you have an alkyl group, or there is a way you can restructure it, you must give it the lowest count. By the time we get deep into the class, you are going to understand what I mean by the lowest count. Now let's check this as well. Alkyl group or branches, or you can say alkyl group or branch group, are regarded as number 1, we have methyl group. Whenever CH3 is forming a branch, we call it methyl because it is only one carbon that is here right now. Whenever CH3 is forming a branch, we call it methyl. Whenever C2H5, remember I said we must firstly determine our parent carbon. That is very crucial. After we have determined our parent carbon, we can now extract the branch. So if the branch is CH3, it is methyl, and we are going to ascribe number to the position where our methyl falls. C2H5, that forms our attached group, or that forms our substituent, we are going to name it as ethyl. Then if it is C3H7 that formed our attachment, we call it propyl. These are the ways by which we can give names to our branches. Having considered all these factors, let's check our first structure here. Look at this structure closely. Look at this structure closely. This is examples of what we call branch hydrocarbon, and it is at the same time performing isomerism. Now look at this. So if you are to count this carbon, the structure you are seeing on your screen now, if you are to count it and then obey the rules of naming, we have how many carbon as our parent carbon. That is the first thing we need to consider. So if you are counting now, we need to consider the parent carbon first. And the parent carbon is propane. How do I know? Irrespective of how you are counting this compound, you are going to have 3 carbons as the longest count. Let's say we start counting from our left. 1, 2, this is the 2 carbon, then 3. No, we started from the left. 1, this is the first carbon, this is the 2 carbon, the second carbon, and this is the third carbon. If you are counting straight, even if you are counting bend, you still have it like this, starting from here. 1, 2, 3. So let's pick the straight one, so for easy naming. If you are counting from the left now, this is the straight one. So that's the longest carbon here is 3 carbons, and 3 carbon is called prop, and the family is alkane because the bond in between them is single bond, and that is why we have this propane first. Now coming back to this one, this is now the attachment. This attachment, how many carbon is there? I have mentioned it before that if 1 carbon is forming an attachment, it is called methyl. So this is an attachment, and the name of this attachment is methyl because this is CH3, C bonded with 3 hydrogen. So this is methyl. And if you check which number does it fall to, it falls on carbon number 2, and that is why we have 2 methyl propane. This methyl is on carbon number 2, and the parent name, the longest one, is called propane. If you count the total number of carbon in all, it is 4 carbons in all. 3 carbons here and 1 carbon from the attachment, which means that this compound you are seeing is an isomer of butane. Is an isomer of what? Butane, which is carbon number 4. This compound, this 2-methyl propane, is an isomer of butane. Why? Because total number of carbon here is 4, and if you count the total number of hydrogen, it must be 10 as well. So in the light of that, it means that this structure and butane, normal butane, their molecular formula is the same, because normal butane we have C4H10, and this compound too, if you count the total number of carbon and total number of hydrogen, it will also be C4H10, but their name is different. You have normal butane, and this one is 2-methyl propane, which means that this is an isomer. This compound is an isomer of butane. In the next class, we are still going to consider more structures and more isomer. Thank you for coming to the class. See you in the next class.